Welcome student to yet another lecture of trigonometry. In this lecture, we shall continue few more show that problems. So on your screen, whenever we start solving the show that problem, we must have our formula list ready. So the formula list is there on the screen. Again revise the formula. In the formulas, our important formulas are the identities. They are used most frequently. Then the inverse formulas for replacement or changing the ratio to the basics one, that is converting few ratios, that is the four ratios, for example tan, cot, sec and cosec are converted in sine and cos ratio. Whereas the down two formulas of tan and cot, they are also used to convert sine and cos into basics. That is, tan is converted in basics, cot is converted in basics, and sometimes if necessary this complementary angle formula will be used. So be sure that whenever you are going for show that problem, practicing in your house, you have this list ready. Okay. So the problem is on your screen. Prove that cos A upon 1 plus sine A plus 1 plus sine A upon cos A equals 2 sec A. So take the left hand side of the show that problem. So left hand side is cos A divided by 1 plus sine A, then a plus sign, and 1 plus sine A upon cos A. Now when you observe this, you will find in the first fraction or in the first term, we can say the numerator is cos A, whereas in the second term, I shall take the laser. In the second fraction or term, the denominator is cos A. In short, you will find the numerator in first term is cos A, the denominator in the second term is cos B. Similarly, the denominator of the first term, that is 1 plus sine A, the same is there in the numerator of the second term. So we will just have a color for it. Okay, so cos and cos are colored as green, and 1 plus sine A and 1 plus sine A are taken as blue. Now since there are fraction, we will try to have a common denominator. The best way is to cross multiply, that is cross the cos A to this cos A and this 1 plus sine A to this. Actually it is not cross multiplication, it is the way of finding LCM, HCF type, and we go for triple multiplication. I'll show you the triple multiplication here. So this cos A will be multiplied by cos A, then this denominator will be multiplied by this numerator, that is 1 plus sine A multiplied by 1 plus sine A, and then the entire this denominator will be multiplied with cos A in the denominator. So this is called as triple multiplication. Okay. So now when you do the triple multiplication, you will get cos A square plus 1 plus sine A square. Since the terms are same, we make the square. Cos A into cos A square, then 1 plus sine A into 1 plus sine A will be 1 plus sine A the whole square, and in the denominator 1 plus sine A and cos A are multiplied. Now here this 1 plus sine A, this you can expand. So for the expansion, you have the formula A plus B equals A square plus 2AB plus B square. We are interested in expanding 1 plus sine A. So 1 plus sine A the whole square will be 1 square plus 2 sine A plus sine square A. So using the expansion formula, your expansion is ready. So on expanding 1 plus sine A the whole square, we get cos square A, and the expansion is written here 1 plus 2 sine A plus sine square A. The denominator is kept as it is. Now in the next step, this cos square A and the sin square A, they are brought together. In short, we rewrite the terms, and on rewriting you will get cos square A followed by sin square A, and then the two term, that is 1 plus 2 sin A. So the step will be in this way: cos square A plus sin square A, then 1 plus 2 sin A is written ahead. The denominator is kept as it is. Now here, cos square A plus sin square A, this is an identity, and its value, just if you see in the formula list, it is 1. So we can replace 1. In the working, we will write the formula that which identity is being used. So it is here sin square A plus cos square A is equal to 1, which is taken in your pinkish color or pink color. So now we will replace this identity cos square A plus sin square A by 1, and that 1 we will write it in the pink color. Okay. So this is the identity replacement 1, and 1 plus 2 sin A are the things which are already there present in the numerator. Rest denominator 1 plus sin A into cos A is written as it is. Now in this numerator you have 1 plus 1. So just add up this and keep rest of the thing as it is. So it will be 2 plus 2 sin A. So that is 2 plus 2 sin A. The denominator 1 plus sin A into cos A is kept as it is. Now in the numerator 2 plus 2 sin A, we can take 2 common. Okay, so on taking 2 common, you will get 2 bracket 1 plus sin A. So that step will be like this: 2 bracket 1 plus sin A, the denominator is repeated or kept as it is. Now note, in the numerator 1 plus sin A, this bracket, and in the denominator 1 plus sin A, these brackets are same. So they will get cancelled. So on cancellation, what remains is 2 and cos A. So write that 2 and cos A, that is 2 upon cos A. Now here 1 upon cos A is equal to sec A. So this formula we have 1 upon cos A equals sec A. So you can replace 1 upon cos A by sec A and keep the 2 as it is. So it will be 2 sec A. So you have on the screen 2 sec A. Now this is the right hand side. Thus you have proved the left hand side is equal to right hand side. So this was the first problem. Today we are going to solve few more problems. Therefore this problem is given as 3A. Now we shall move to the next problem. So the next problem is there. Now before going for the next problem, or whenever you start for a new problem, again you have to make sure that the list of formula is there with you. So the list of the formula is there on your screen. Again, I will repeat it: identities, inverse formulas, and tan plus cot formulas are important. These are used very frequently. Now the problem is on your screen. Now it is 1 upon 1 minus sin A plus 1 upon 1 plus sin A is equal to 2 sec square A. So take the left hand side. You will note that 1 minus sin A is the denominator in the first fraction, and 1 plus sin A is the denominator in the second fraction. Now just change the color. So on changing the color, you will get one part is in green color, other is in blue color. Now as we have done in the previous problem, whenever there are fraction, one of the way is going for triple multiplication. So that triple multiplication we will show you also. So this denominator 1 plus sin A will get multiplied with this 1. Then this denominator 1 minus sin A will get multiplied with this 1, and then this 1 minus sin A and 1 plus sin A will also get multiplied. So that step will be 1 plus sin A multiplied by this 1 is written in the blue bracket, and this 1 minus sine A that is crossing towards the right side up, that is written 1 minus sine A, green in color, and both the denominators are multiplied in the denominators. Okay, so laser point. Fine. Now in the numerator, all the terms are free. When we just open the bracket, this plus sign will get multiplied inside the second bracket and you won't find any change. Thus the bracket will go off. Whereas in the denominator, it is 1 minus sine A and 1 plus sine A. So here you can use the expansion formula A plus B, A minus B. So you have here the formula A plus B, A minus B is equal to A square minus B square. We are supposed to expand the denominator, which is 1 minus sine A, 1 plus sine A, that is 1 square minus sine square A. So now we will be expanding the numerator. At the same time, the denominator is replaced by 1 minus sine square A. So here you have the complete numerator is open and the denominator is being replaced by using the formula here from the expansion part. Now observe the numerator very carefully. You will note that we have 1 and 1, so that can be added up, whereas plus sine A and minus sine A will get cancelled. And then this identity, that is 1 minus sine square A or 1 square minus sine square A can also be replaced. So here we cancel it. Then for replacing this, we have an identity, that is sine square A plus cos square A is equal to 1. Transfer the sine square A to the right hand side so that you will get the denominator here, which can be replaced with cos square A. So add up the numerator, it will become 2 and replace the denominator. So on replacing, it will become 2 upon cos square A. Again, as we have done in the previous problem, it was 1 upon cos A. So 1 upon cos A, the identity is, the inverse formula is 1 upon cos A equals sec A. Now if you square the entire thing, it will become 1 square becomes 1, cos square becomes, cos becomes cos square, and sec square will become, sec will become sec square. So this will be now replaced. 1 upon cos square A will be replaced by sec square A, and this 2 will be kept as it is. So you will get 2 sec square A. Thus you have proved the left hand side is equal to the right hand side, which is there. So your problem is complete. It has been proved now. Now we shall move for yet another problem. So the next problem, as usual, bring the list of formulas, check it out. Then the problem is on your screen. The problem is sec theta plus tan theta in one bracket. In the second bracket, it is 1 minus sin theta equal cos theta. Now take the left hand side. We have sec theta one ratio, tan theta another ratio, and sin theta yet another ratio. So we will change the colors here. So on changing the color effect is on your screen. Now here sec theta, tan theta, and sin theta. Here these two ratios, sec theta and tan theta, they can be converted in basics. That is sec theta, the basic is 1 upon cos. Tan theta, the basic ratios are sin upon cos, rest keep as it is. So converting it in basics, so here we have on the screen sec theta is equal to 1 upon cos theta and tan theta equals 1 up sin theta upon cos theta. Now here in place of theta, whenever we use the formula, you can use any. Sometimes A is there, sometimes P is there. It doesn't make any difference. So whatever is there in the problem, that you have to continue writing in the solution part, whereas this formula which are given for support, they can contain A, P, theta, sometimes alpha, beta. It doesn't make any difference. So now here your sec theta will be written as 1 upon cos theta, tan is written as sin upon cos, whereas the other part is kept as it is. Now observe the first bracket. Now in the first bracket, the denominators in the two fractions are same. So you can directly add up the numerators. So when you add the numerators, it will just become 1 plus sine theta upon cos theta. So denominator is written once. So your step is like this, and the second bracket will be kept as it is. There is no modification necessary there. So it will be 1 plus sine theta upon cos theta. Now, in the second bracket, draw a denominator here, and here the denominator, draw the division line, the denominator is 1. So you'll note here, now you have two fractions, one fraction in the first bracket, second fraction in the second bracket. Okay, so now this numerator 1 plus sine theta and 1 minus sine theta from the second bracket, they can be directly multiplied, whereas this cos theta will be multiplied with the 1. So now the multiplication effect will be somewhat like this: 1 plus sine theta, 1 minus sine theta divided by cos theta. Fine. Now this 1 plus sine theta, 1 minus sine theta, again it can be expanded by using a square minus b square formula. So that formula is on your screen: a plus b, a minus b is equal to a square minus b square. Then 1 plus sine a, 1 minus sine a is equal to 1 square minus sine square. So this numerator can be replaced as 1 square minus sine square a, but we have theta, so in the solution part it will be written as sine square theta. So the step will be like this: 1 square minus sine square theta, denominator is kept as it is. Now again 1 square minus sine square theta, you can replace it by using the identity. Your identity is sine square a plus cos square a is equal to 1. This sine square a transferred to the right hand side becomes 1 minus sine square a, which is equal to cos square a. So naturally this numerator 1 minus sine square theta can be replaced with cos square theta. So on replacing, you will get cos square theta upon cos theta. The denominator is kept as it is. The replacement is there. So here the replacement can be shown to you. This numerator, use this formula, and then from here you will come to this numerator. Okay. So here is the laser. Okay. So now this cos square theta, the numerator, can be written two times, that is cos theta and cos theta. Denominator kept as it is. So your step will be cos theta into cos theta upon cos theta. You can cancel the numerator and denominator cos theta. So what remains will be only 1 cos theta. So that things are cancelled and the remaining is written here. And now this is your right hand side. So you can have here, that I'll just connect here today. So this is your right hand side. Thus you have proved that left hand side is equal to right hand side. So students, today we have taken 3 problems. Revise this problem again and again because they have now some similarities, and now as you go on solving problems, you will understand that the problems, some of the identities are used very frequently. Which are those identities? Those are used frequently will be known to you. So today's lecture, this is sufficient. Now thanks very much for watching. You were with Life with Khandekar sir. If you have liked this lecture, press the like button. Subscribe to my channel, KIT Classroom. Thank you very much. Good night.